Let us start with data preparation and workflow management. So welcome everybody. Good seeing you. The attendance is up, 57 people, so amazing. So at least that signals some sustained interest, and also that you still have a little energy left after maybe having joined my other stream this morning. Let's get started. So actually, it's quite an exciting session. So what we got today is we're gonna talk about version control, and we're gonna get things, set up and work through the tutorial on GitHub, and then try to apply our skills on real stuff. And in the second half, I will go through the GitHub repositories that many of you have sent in. So I received many links. Earlier on, I received a question, is this part of the grading? Well, I'm not taking notes today on who does what, and there is no formal grading on whether you submitted anything or not. But what I'm telling you today, in the second part of that stream is quite relevant for your projects, because I'll actually compare, what you have worked on with kind of my expectations to make sure that you're on track. So every week you can submit stuff. I'll pick out a few examples and comment upon them. So that's a little way to receive feedback on your work. Let's talk about Git and GitHub. I think pretty much all of you probably worked on it. So can somebody explain what's the difference between Git and GitHub? So Git is a very, very powerful way to version files. So you can always roll back to any kind of version that you've ever worked on before. And when Git got invented, it's kind of, let me just clear up my screen for now. Whoops, clear. It's used in the command line. So, by typing Git and then some kind of comment, you can use Git. And then eventually people realize, well, collaboration is nice using Git, but maybe people are looking for more. And GitHub started to exist, which kind of comes on top of Git, right? It uses Git, the file versioning thing, but it adds an entire ecosystem of amazing tools that help you to program, such as a public view of a repository. And GitHub, exactly, it's a place to share and store your code. Git, there is no Git code, right? It's just your code for any kind of project that you're working on. So you could also describe it as kind of a social networking platform where you can see others' projects and collaborate and have a board and these kind of things. That's exactly the thing. So I hope you were all able to create an account on GitHub. Just click on sign up and use whatever, probably you can use Google also to log in. Probably you should all have an account. If you don't have an account yet, please do that. Then I hope all teams were able to already create their GitHub repository. See, there is no team repository, but typically you choose a team captain, and then that is kind of the main repository that you're using. So why are you keeping, things in a repository, you may wonder? Well, to many, it's just a way to collaborate, but for many students in analytics firms, it's also a way to have a digital CV, right? So when I send out my, I have a CV on my website, when other researchers want to check me out and make me a giant, incredible offer to join another research group, right? Then, the GitHub profile is there, and that's a portfolio of my work, which I, share in public. And, people will kind of see that, I got this course running, there's a little description right here, and actually it's public. So if you want to run your own course, it's even a template. If you want to run your own course, you could just go here and click on fork, and you have your own very copy of my course, and you could just change the title and name, and search and replace your name with my name, and you have your own course, right? And like this, there are a bunch of other things on my profile. So what you should realize is that the most important thing is, well, obviously having a good description about your work, but also having a good README when you get in, right? A README document on your GitHub profile is the first thing people see, and it renders almost like a website, right? Next to seeing code on GitHub, you'll actually get a really nice looking overview about what is here. And that was part of what you worked on today. And it typically has a motivation on what's there, who's worked on this, and how to use this repository or how to contribute to it. It depends on kind of the project that you are working on and what that content of your README is. I've seen some repositories which don't have README, right? So that looks very bad, and I'm guilty as charged, because if you look at, whatever, this repository of mine, it doesn't have a README, so maybe I should add one, right? It says something here, but that was back in the days where, wow, 6 years ago. So I wasn't that good on adhering to what I teach now. So it's a journey, ongoing journey. So actually, let's try to explore Git a little bit by clicking on Explore GitHub. And I've shown that to you earlier in another course. But if you click on topics in GitHub, I'll put it in the chat right now, you can explore certain topics and maybe identify projects that with your skills you eventually are going to be able to contribute to. So for example, something that I find super exciting is that to kind of see the community. To scroll down, I think there's a whole community about Bitcoin, and the repository, which is the most popular repository right here, is the entire source code of Bitcoin, right? So if you're getting more into this, getting more data savvy, you can actually try to see how this blockchain is being built. Of course, this course is not about code in whatever language Bitcoin has been developed in, but it can be pretty exciting. Other topics that I find extremely interesting to take a look at are COVID-19 projects. So let's take a look. Maybe we'll encounter some research project, novel corona cases. So what is this actually, this project? I think this is a data project. It's the Johns Hopkins data set that always gets cited in the media, right? So I think it has all of the data sources that report on COVID cases across the US and non-US data. So let's go to Netherlands up here, Netherlands, there you go. And I think that somewhat is an official data source for COVID-19 data in the Netherlands. And I haven't checked on whether that actually works, but yeah, looks like a dashboard that has some data from which we could extract data. By the way, I've never seen that dashboard before. So like this, you can use it to explore projects. Something else that you could do, you could look for, our research projects and find, oh, I've exceeded the limit. Is that true? GitHub.com. So maybe I should log in, sign in, my login credentials. Maybe I can now R research and look for projects right here. So something that's quite, well, the search didn't really get me to good places, but well, something that happens on GitHub too, for example, in my case, is that I develop packages for others to use in R, such as the music metadata package. And I'll put the name, URL in the chat. It's actually quite a simple package, but it's useful to people. So overall, it's an extremely useful tool used for collaboration that you should adhere to. And something that I, for example, discovered too. Oh, it's not this one. Just a second. Is that many famous universities, such as the Graduate School of Stanford University, use GitHub too to entirely manage their research projects. For example, this is their manual to onboard new collaborators to working on research projects. So it's not only a thing that computer scientists use to develop software, but it is something that researchers like us, we actively use to kind of coordinate people and explain to people on how to collaborate on research projects. That is why it is a very interesting skill for you guys to have. So the tutorial of today's session introduces you to some of those practices in GitHub. And a very important concept in working with Git is the so-called Git workflow. And I'll show you what I mean by that by opening up the tutorial in my browser. And it's a little slow to open. So when we work on code in empirical research projects, what you probably all do at this moment is you write some code, you save it, and that's it. And then you write some code again, and then you save it. And that's not surprising that you do it this way, because that's how we work on Word documents, right? That's how we learned to work on PowerPoint presentations, right? We work and then we save, we work and then we save. But the thing is that all that we've done before doesn't really, involve a collaboration element. Even if we go to like Google Docs, we just type a text and it automatically gets saved. But when we want to collaborate on code, we have to do things a little different, because we need to decide on what changes that we've done we actually want to share with other people. Suppose you're working on code, right? And you would use Google Docs to collaborate on code. Now you could change something, another one could change something, but you'll never really be sure on whether your code still runs or not, right? Because I don't know, there may be a typo by somebody and then it doesn't work and you correcting the typo but at that time you have made a mistake and some people can't like kind of continue. So Git, when working in Git, it's a little different, right? You still work in a document and code and save, but there's a new workflow to let other people know that you have made changes. And I'll walk you through that workflow a little bit. And I think the best way to learn this is by downloading the Git cheat sheet and by using the commands which are up here, and I'll show you those commands. And I think the best way to get started is, for example, by using our own course website and trying to make some textual changes to it. So what I invite you to do is I invite you to go through your GitHub profiles. Well, actually open my website, dPrep, just a sec, repositories, course dPrep. To open this page, I'll put it in the chat right now, to open this page while being logged into Git. So can you all do that? Good. So open it up in Git. And before we start working on a workflow, what we do is we make a copy of this project, because you guys are not a collaborator of mine, right? I can't allow you to make changes to the course page without, me checking those changes, right? So what you do is you create your local copy of a project by clicking on fork. Why is it called fork? So, up to this moment, there's just one dPrep course, right? And now we're creating a copy, and Joanna creates a copy, Robin creates a copy. It looks like a fork, right? Because this has been just one course up to this moment, and now it's broadening up because there will be multiple branches of projects, right? So go to the website and click on fork. And I'll do it like this, but I will not fork it right now because I'll retain my own copy of this because I want to work in the main version right now. So click on fork, and what you'll see happening is that my Hannes Dada username gets replaced by your username. So now you're working in your copy of that repository. Okay, you see that happening? Good. Right now, just open the terminal anywhere on your computer and navigate to a directory where you generally store stuff. So for me, it's research projects, and I'll call this temp dPrep because, I want to work in this directory now. Okay, so just navigate to some directory that you feel comfortable working in on your computer. I use the terminal, but what I recommend Windows users to do is to open git bash. right? And how does it look? I will open up my Windows computer to show you how that looks. Here we are again. So what I do is I go to search and I type git bash and open it. Right, and then you get the same kind of thing. And then you navigate to a directory that you feel comfortable in. If you find navigation to be like difficult, what you can do instead is you can navigate to a folder, let's say to some kind of documents folder, and right click and open git bash here. And then git opens in this folder, which is a better way to get started. Okay. I'll switch back to my Windows machine right now, to my Mac, because by now I feel more comfortable on my Mac. So now we want to download the source code of this thing, and what we're going to use is the git cheat sheet. And to set it up, to get like your copy of my project, you do git clone, and then this particular URL of your thing. It's not the GitHub Hannes data course dPrep, but it's your very own username and then dPrep, right? So remember, I'm checking out my own copy. Please do check out your own copy. So your username. So git clone https github.com, your username, and then probably it's called course dPrep. And now you're retrieving a full copy of this project on your computers. And it's quite large, so it takes a little while. You should do some cleaning up here, but I think for the demo it should work. So we're receiving the objects, and I'm almost done. So I could go to this folder, temp, where is it? Temp dPrep. And now you see this course kind of populating right here. Something very important to do before you're able to run this is that this course runs with so-called Hugo Framework. So this is like a little web server that I can start up on my system to do this. Probably if you work through this tutorial, you have installed it. If not, this demo will not run, and I think to install it you will first have to do it via this page. So
I'm not really sure basically where to click and what to copy paste.
Sorry,
I tried some things, but it gave an error, so I shut it down and I restarted it.
Can you show me the error? Do you have Chocolatry? Do you have this package manager?
I don't think so.
Yeah, then you can't install it. Okay, Windows. I haven't installed it on Windows in a little while, but probably you need to spend a little time going through this if you want to run Hugo on your side. But for now, I would say, yeah, it takes a little while to go through this. So I think you can run this example right now in this course without having Hugo, but you'll not be able to see it come alive. All right. Other students have this, but you can then spend some time later to get set up. And
okay, thanks.
Oh, yeah, Gijs has a good comment. There's a video at the end of a page. I'm not sure which page, but yeah, this one probably troubleshooting Windows installations. Is that Gijs? So just go through this. Yeah, watch the window. All right. So, but what we have is, I hope, who has been successful cloning this thing? So, after running git clone to get this on your machines. Who has been successful cloning it, and can you actually see it? Put it in the chat. Yeah, it works fine. Okay, good. So let's explore this. All right, let's explore this real quick by going through our folder, and I'll do this. I'm sorry, I'm not sharing my screen, I realize. Let's do this by going through this folder on your machines and looking at the files a little bit, right? So we get like a content directory where the things of this course, and you probably recognize those sections, like the about page, the building blocks, the course with like projects, where I have like markdown documents that I have written. For those that have Hugo, you could just go into this directory, cd course dprep, and being in this directory, and just type Hugo surf. And then this website server starts to like run, and you can look at the course page yourself. And what I'll like to do is like, I'll just open my editor, which is Adam, and I'll open this dPrep folder in here to have a more convenient way to look at the source code of my course. So I'll put it next here. And for example, you can go to the About page. Sorry, this is the front page of this course. And now the nice thing that you do when you change files, for example, you can change the source code to learn how to engineer and save it. And you see that it automatically renders in your browser. Well, in this course, it's not like about learning Hugo or how this framework works, but it's a very accessible way to see how, you know, source codes map into, for example, websites, or how source codes later on map into our projects. Okay, but it's about Git. So let's go back to our terminal. By the way, if Hugo is running, you can press Command T to open a new tab and do Git status. With Git status, that's now our Git workflow. We have this local project, and now we're starting to work through this local workflow. First, we do Git status to see what kind of files have been changed since the last time that you changed anything. You know, change the index MD in the content folder. All right. And then type Git status. Okay, you need to let me know. Okay, other people. Yusuf, thank you. Oh yeah. All right. Do you see this marked in red when you change the file and type Git status? Anybody who doesn't see it? Then start sharing your screen and I'll walk you through it. Who thinks like, oh, I'm totally lost. I want to see your screen. I want to help you.
Don't see the message.
Good. Can
I
you?
don't see it.
By the way, the question was, does it matter whether you git clone the URL with Git or without Git? It doesn't matter usually. All right. Yeah, exactly. So can you? You're not in the directory yet. You've cloned it, but you still need to go to the project. Can you write cd space course? Yeah. Stop typing. Press tab. Tab is a way to auto-complete. See, and just press enter. Now you can do git status, for example. And you have changed, right? So
yep.
Your question, maybe you've worked on stuff, but you don't really know what you've worked on, right? Sometimes you write source code, but you know, what were the changes again? And you can write git diff for difference. Git diff. I'll put it in the chat right now. Git diff. It's with small g. Jonah, what about Windows 10? Sorry, I missed that one, but oops, doesn't matter. All right, so yeah, you need to. Zoom is not Git. Happens to us. All right, so we did git diff, and we see what is the difference in these two files, which is like super handy when you like code to kind of see what are those changes. Good. We've saved the file, and for us it's there, right? But now we want to like inform like the GitHub website that we've made this change. And how this works, first of all, we need to tell Git, again, git status. I'll type git status a lot of times every day. We need to tell Git that we want this file to be versioned. So the first thing of this versioning process is to add it to a stage, the staging area. So it could be that you've changed many files. So for example, let me also like just change something on the course page, and I'll type like, this is the content, and I'm saving it. I do git status, and now you see that two files have changed, but actually ones I don't really want to save because this was just like some exploratory stuff that I've done. So I can type git add, and I want to add the file contents / index, and I'm using tab to autocomplete because I'm a lazy writer, so I don't want to write like everything. And I'm adding this to the staging area. Do git status again now, and you observe that this file has turned green. And like this, we can add more and more stuff to the staging area. You know, there may be like tens of files that you've changed that you want to commit. Right, but still nothing has changed. I didn't like transfer any data to GitHub yet. So what you can do now is you can, after you added stuff to the staging area using git add. By the way, on the cheat sheet, where's the cheat sheet? We are here, right? Git status, git add. And we now committing our changes to Git. Git commit -m, and we're going to give it commit message, which means like this is a little message display to all the users of this project to explain the change that we've done. And this is just a temp change showing students how to change code. Quotation marks, enter. If I run git status again, that file which I've changed is gone. So, because the file now is versioned. But the versioning just happened on your own computer. We haven't shared it with Git yet. So the final thing that we want to do is we want to push our changes to Git, to GitHub. So we're writing git push, enter. And that's it. So now you have committed your changes to your own repository. What you can do now is you can browse through your repository, which in my case is Hannes data, but in your case, course dPrep. But in your case, it's your username and then course dPrep. And after pushing, you'll see that something has changed a minute ago. That's exactly the change that I've just done. Temp change, showing students how to change code. All right. You can go in and actually see that change. Git is actually a very convenient interface. Click on history and you'll see on how, what kind of change has been done. You can browse it here to kind of explore it. Let me see. Browse the repository at this point. This is view at this point. This is, I think, the change that I've done. And it's very nicely displayed on what kind of code I have changed. All right. Give me your URLs. Put in your URL with the course ODCM. I want to see on whether you succeeded. Just give me your username and the name of your repository like this. Just copy paste it in the chat if this has worked. So let's explore. Oh, yeah. You still have to submit username and password. Yes. Just Google for it on how to automatically do this. On Mac, it's easier thing than on Windows. To all people who have already Git, but who didn't install Git properly on their system, I suggest you updating Git because much of the things have changed and it's better working with a more recent version to get this password thing sorted out. So who has this thing done? Who can give me a username, who can give me a URL to your GitHub repository of this course version? Anybody? Yeah, thank you. Thank you, Chang. So I'm opening Chang's link and well, actually, 2 minutes ago, you did something with a README. So what did you do to my README? Anyways, that's an interesting thing, right? So great, good job. So this is how it should look like. Now let's pretend your change, Chang, is like so amazing that you want me to integrate your change. In open source projects, that's like this, right? So like, the open source project maintains a project or a research project, or like your team captain maintains the project. You as a team member, you have contributed some stuff, and now you want your work to be integrated with the work of other people. How this works is that you initiate a pull request. And I think, and now I need to need to actually go back to my repository real quick to kind of, can I actually make a pull request right here? Where are pull requests? Because course, dPrep. There should be something like create a pull request. Maybe it's somewhere here, Trang. Do you see that somewhere with create pull request? Yeah. Otherwise, share your screen. Can you share your screen? Yeah. So, can you go up a little bit? Where is that? Create pull. Contribute. Yeah, open pull request. Exactly. Exactly. And yeah, just go down. Just go down. Okay, you don't have to comment on this. Okay, good. Just go up again and click on create a pull request. So just a second. Oh, before you do. So my base repository is like my repository, the main one, right? So this is going to be your team captain's repository. And on the right hand, it's the head repository. So that's your own one. And now you're making this change and you're trying to ask me to integrate it. So please do that. Click on create a pull request. Yeah. Now describe it, leave a comment and say like, this is just a dummy version on. Yeah, just like click on create pull. Right. Now I'm taking over again. And I'll share my screen. And right now I got an email probably notifying me about a change. And here's the student trying, and she has done a funny joke and changing this website. So I go through this website, through your pull requests, if I'm the manager, and I can review those. So for example, all right, there's a comment. So what did Trang change, by the way? Okay, let me see. Files changed. She added a haha to data preparation and workflow management. That's a great change. I really love it. So I want to integrate this now. So I click on review changes and I can just say awesome for a first test. And I'm just submitting this for review. I like this. And I can click on merge pull request. And now her changes, the code that she's written automatically gets merged to the real thing. So, you know, once again, it's a little complicated maybe for you to start out, right? But okay, you have like your team lead having one GitHub repository. This person is in charge of everything that you're doing in this project and guarantees that your master, your main branch is intact and works. But you work on projects independently a little bit, right? Because you want to try out some stuff. So you're forking it. You're taking your own copy to your own user account and you're fiddling around with it. When you're happy with all of those changes that you've done, you're adding files that you've changed and you're happy with to the staging area, commit them and push them to your own repository. And you'll perform these cycles multiple times a day, right? You may like change another file and work on this and fix that until you're happy with all of the changes that you've done. And when you are at the end of the day, for example, what you're doing is you're going to your GitHub profile website and you're issuing a pull request to make sure that your changes are being integrated by your team lead with the whole thing. Team lead gets notified, sees a pull request. By the way, now I just have like one pull request from, I think, the last time that I gave this course. And that person is in charge of integrating things on the site. And by now, probably you would already have noticed if you go to my profile that right now the official version of this course README contains the haha, right? Because I've like integrated Trang's changes. You know, Hugo is something that's like super useful. But you know, it's not the core of this course. But if you learn a little bit about how, you know, running a website works, you can have your own profile website that you can put on Git, and it's going to make you look extremely cool, right? That's like somehow why I do this. The other reason why I use Hugo is that Tilburg Science Hub is entirely developed in Hugo, and in the same way that we've just cloned a website, the course website, you can clone Tilburg Science Hub and contribute to it. It's like super, super easy to do, and rewrite the tutorials that we've done, or contribute your own tutorials. So I'll go through the chat for some questions. Danielle, your question was, but if you have made your team members collaborators, do they still need to pull requests each time they want to add something? Well, okay, here's the thing. If you make them collaborators, you can all work in one repository, which means they don't do git check out their username, their fork, but they just check out your main repository and they can work on it. The reason why I presented to you this, forking way is that, in a matter of time, you'll maybe want to contribute to publicly available projects, and where you don't have read and write, where you have write access, but not read, where you have read access, you can get that stuff, where you can really write to it. That's why forking is the way to go. It's also a little better because forking, because you're making sure that you learn the workflow, how it really works, and you're making sure that you don't break the project, so that one person is in charge of this project. So my suggested route is really that you work through pull requests, but technically it is possible to all work in one repository. In fact, I do that with many of my collaborators because I'm sure they won't mess around with my stuff. But the pull request is more of the open source way of contributing. That's why I'm doing it. But it's ultimately up to you. When grading your project, what I'll do is I'll look at the version history of your project. So for instance, if this, let me go to Trang's repository in the chat. So this is the main project. And what I'll do is I'll get the history of all contributions to this repository. So let me go to code. Let's not contribute, which I want, commits, right? So I'm going to look at the commit history and see, like, how have people contributed? Is just one person that's doing all of these changes? Is multiple persons doing all these changes? Are there going to be like some pull requests, or is it just like, I'll assess in a way how you've collaborated on this. But, the choice is essentially up to you and how you want to do it. So check the grading guidelines if you have any questions about this more, and I can clarify. Julia, you've missed something. How do you get your own website after cloning the link? Well, after, what do you mean actually, Julia? Oh, how to get on your own website? You mean you want to run your own website in the public? Is that what you want, Julia? So, you can push the site to GitHub. Also, I'm using a service called Netlify, so I get it to my .com domain, Netlify. But run Hugo page on GitHub, host on GitHub. So this is a tutorial on how you can push your own version to GitHub. We also have a tutorial on tilburgsciencehub.com that does this. Tutorials, create your own website in 15 minutes, which is this link, which shows you on how to do that. Okay, I'm answering some more questions. Amber, we all work as contributors. So yeah, that's kind of okay. I mean, try and experiment with it. This is all about learning. So yeah, try both ways. What if you only want a part of the pull request? If lots of changes were done, you can select parts? Yes, of course you can. Right, so can anybody give me another pull request, please? Have you done some changes? Issue a pull request to my site, and I can like change 2 files, and I'll try to just accept 1 change. Joanna's question: how do we know the things we will add will be accepted? For example, I see this branch has no conflicts with the base branch, and then I see merge pull request. What does this mean, merge pull request? Well, merge pull request essentially means that you can merge these code files without creating any error. Sometimes 2 persons make changes to the same file at the same moment, and then Git doesn't know how to combine these changes in one single file. And then typically you get a little error asking the project lead to kind of go through the changes, really carefully take a look at it to understand what's going on and how to integrate this code. Okay. Sabine, you still can run Hugo. I'll take a look at it in the break right now. All right. Oh, by the way, yeah, that 4 question. Okay, 4, yes. Joanna, you request pull request. Perfect. Zoom session changes. Okay. Well, it wasn't Joanna, it's Gijs. So let's take a look at this. Let's look at the files that he has changed. Block, Zoom sessions, post. All right. There's just one file, but I can edit the file, for example, in the browser. Okay, these are your changes and Zoom session of today. So I'm making some changes directly in the browser, maybe because I'm not happy with kind of the spelling that you've done, for example, like this. And like this, you can edit pull requests too before you're changing them. And you can commit changes and then do the same thing. I could say, actually, I want to comment on it. I can approve, or I can request you to change. But let's me just approve, submit. And in the end, I can merge this with my main thing, confirm, and then close the pull request automatically. So this change also goes live in a second. Okay. Perfect. Can we revert a commit on GitHub's website, or we need to use git bash? I don't know how to do it on a GitHub website. I think I would use git bash. By the way, for those who are like feeling really, really scared about this, whole git bash thing, there are amazing Git clients that you can take a look at. And I think I have given you some examples on this. Like source tree app, for example, is like an amazing thing that does the same thing like I do on the command line with a graphical user interface. Okay, so maybe you want to check that out. We're going to go on a break. I'm going to figure out what goes wrong with Sabine, and I'll see you back at 11:45. So, and I actually need a little break, like a minute or two, and I'll be back for answering these questions. All right. So thanks a bunch so far. All right. I'm back for questions. Sorry, it took a little longer than expected. So any pending questions before we get started with everybody?
Yes, I have one.
Yeah, Bram.
I managed to install and clone, but what did I need to do next?
Show me your screen. Show me your screen again, please. Yeah. All right. So you've installed Git. All right. So what to do next? You mean?
No, well, I cloned it. I cloned the repository. But what do you need to do next?
You enter this directory, right? And I think something that I'll put this in the chat for you. Part of this tutorial was on how to use the command line, how to like enter commands here. Can you type CD space and then course and press tab? No, tab, not enter. Press the upper key now. No. Yeah, okay, tab. Yeah, there you go. That's the directory. Enter. And now type ls. I'll put it in the chat for list, whatever, ls. Yeah, enter. Now you see the files in this directory, right? So you're in. So now you can make changes to it, but probably you want to install an editor. Do you have like an editor that you like to use? Like, do you use Atom or?
What do you mean by edit?
Like to edit files on your like programming files, right? So I would just say that you install an editor, and I think it's in the software installation. Is it part of this make? Oh, it doesn't say about an editor. All right. So for example, can you open R?
So
just open R. Do you have R?
Oh, as a yes. Okay.
Yeah,
R or RStudio?
RStudio. Now you go to this directory and you'll open for example, like the README in.
It's still
Yeah,
loading.
it takes some time. So yeah, I think now it's open. Yeah, that's fine. Do you want to close? Yes, close. And now just go open. Open file. Yeah.
Oh.
No. Just open a file. Don't type.
Oh.
File, open file. No, not new. File, open file.
Ah, yes.
Now
Okay.
you go to, yeah, exactly. And now you can, yeah, go to the README. And now you can edit that, right? That file in your code window. That's like how we edit source code, right? It could be Hugo, but it could be like our code, right? So you can make changes to this. Can you go back to your terminal? Yeah. So have you installed Hugo?
No, not yet.
Okay, yeah. So I mean, I show you something else, and that's maybe also cool for the others. So can you click on open again in R? In open file, yeah. And now you navigate to content, docs, tutorials, version control, and you open version control RMD. Error? What is this?
It's still opening.
Oh, it's opening the file, yeah. But this is the tutorial of today. So, you know, Hugo is like one thing that may mess you up if you haven't installed Hugo, but at the very, you know, same thing, you could just install R. Sorry, not install R, work in the tutorial of today's session.
It's still error.
Yeah, maybe you can crash it and try to open it again. I don't know exactly what's going on here. Yeah. Sabine, yeah, just like Bram, you can crash R if it's like going on forever by pressing, you know. Oh, if you close it, amazing. Yeah. I would just try to open this file again. If you experience more problems, I'll take a look at it again. Okay.
Okay. So open.
Yeah, open file. You can, yeah. If that tutorial doesn't work, you can go to another tutorial. Let's try another tutorial. Go to content, docs, tutorials, and let's do data preparation in R. Exactly. Just open data preparation RMD. Yeah, like this. Yeah, you see the tutorial popping up?
Yes.
This is the source code of the tutorial. Can you press knit?
Knit. Sorry, what is
it's this blue button. Looks like.
Oh, here.
Yeah, exactly. Now you're building this tutorial, but you can start changing the tutorial, right? This is the tutorial you're going to work on next week, right? You can just rewrite and make it better, and you know, commit your changes and push back, and to push.
So, for example, if I want to change the title,
yeah,
I edit, I don't know, something like this, or
yeah, exactly.
Okay.
There are just a few things I want to tell you more about Git before we actually take a look at your repositories. So Bram is sharing his screen right now. Thanks, Bram. And what we've done while you may have been absent is that Bram cloned the GitHub repository to his computer. And I showed Bram that, you know, Hugo may be like a difficult thing to run right now, and maybe some people haven't installed it. Another way in which you can try out what I've just like been showing you is by opening the tutorials, which are all usually written in R Markdown. We've talked about R Markdown, I think, last week. You know, it's a way to render documents in a very nice way. So Bram, can you scroll up a little bit? You've opened the, you know, data preparation tutorial. It sits in docs, tutorials, and then some folder. And this is all the source code of this tutorial. When you click on knit, it's getting rendered. So when you encounter things that you don't like in this course, thanks, Bram, this works like a charm. If you encounter stuff and tutorials that are unclear and you have a better way of saying things, a great way to practice, you know, working with Git is just to rewrite it and do the Git work cycle and give me a copy of, you know, issue a pull request so I can integrate your changes. So try it out. I think it's a very powerful thing that you can do. Thanks for sharing your screen, Ron. All right, so I'll go through the chat real quick on whether there are any remaining ones. Sabine, you have a question. How do you open Hugo after doing Hugo Serve? Is that it? Can you show your screen, please? You see this web server is available at HTTP localhost 51735. Yeah, copy this HTTP thing up to the end of the URL and copy that to your browser.
Okay, yeah, I have my browser on another screen, so.
Yeah, but if you click on right click, I don't know whether you're using mouse or these 2 fingers on Safari and do new tab or new browser. Do it not right now on your screen or move the window. Yeah, there we go.
I have it here.
Yeah, there you go. That's the thing. And if you start making changes to the site right now, you can see how they actually look on the site.
How can I make changes?
Like Bram has done, right? So open an editor. I don't know which editor you're using. Maybe I should have been more explicit that editors or something. Well, we're using R mostly, and somewhat I made this detour to Hugo. Open R, please.
Yeah, okay. I will.
And
do
then
the
you
same.
open the source code, the file. These are markdown documents, MD documents. Just open them.
Oh, RStudio.
Yeah, RStudio, sorry. So go, close this one. And in RStudio, just open the files in this directory. And this web server automatically renders your site. Okay?
Yeah, okay.
Good. Thanks for your question. Really useful. All right. There's a question. If I connect a Git to RStudio, it seems easier, right? Yeah, totally. You want to show others how you do this? Share your screen, Vasilis.
Yes, of course. I mean, I have connect here.
Yes.
The RStudio with the Git. So this is the README file. So if I change here, blah blah blah.
Yeah.
I just
Save?
go
Save. You have to
yeah,
save
save first. Then I go to I select the file.
Yes, this is for the staging area. You click commit.
Yeah, commit. Here I just write a message like add comments, then commit.
Yes.
Right?
Yes. And now you can
push.
Yes, exactly.
And now this create like a push request.
No, not yet. The pull request you have to do on GitHub, but it just pushes it to your repository.
Okay. So okay, perfect.
Exactly. Great job. So that's in your account. So when you now go to your GitHub profile in your browser, maybe you can show.
Yeah, that's right here.
Okay, open pull request. There you go.